Okay, transformations of the logarithmic function. Here's my parent function, y equals log base b of x. Logs are the inverses of exponentials. So let's talk about this briefly. If I had an exponential function, it would look something like that, where I have a asymptote down here at y equals 0, which would be my k. Y equals k would be my asymptote for an exponential function. I said these things are inverses, so if they're inverses, they reflect over this line here, y equals x. Okay, when you reflect over y equals x, your domain and range change places. So that means this reflected function would look something like that, where now I have a vertical asymptote. My vertical asymptote would be the equation x equals h. So in my exponential, my range is restricted by my horizontal asymptote. When I take the inverse of that, my logarithmic has its domain restricted by its vertical asymptote. So the range of an exponential becomes the domain of a log. You'll see how this interacts as we move forward. Here is the transformational form of my equation, where I have y equals a times log base b of x minus h plus k outside the argument. We have seen a, h, and k before as we've transformed rational functions and radical functions and the like. It does the same things. So if I look at the absolute value of my a, put in the absolute value bars here, absolute value of a is greater than 1, then I have a vertical stretch. If 0 is less than the absolute value of a, which is less than 1, means I got a decimal here like 0.5, or a proper fraction like 1/4 or 2/3. Then I'm going to have a vertical shrink. Reflections. Again, look to your a. If a is positive, no reflections to worry about. If a is negative, it's going to reflect about the x-axis. So it'll flip the fraction over the x-axis if a is negative. Seen that before. Moving on, vertical shifts. This is an easy one. Plus k at the very end of the function outside of the argument. It's like my kite. If it's positive, it goes up. If it's negative, it goes down. Horizontal shift. Put a star by this one. Okay. What I want to do is I want to take my argument and set it equal to 0. Whatever's with the x, set it equal to 0. So your argument equals 0. So let's see what happens here. If I have an argument of x minus 5, remember the equation is x minus h. So this had to come from x minus a positive 5, right? When I set this equal to 0 and solve, I'm going to add 5 to both sides. And I see that x equals 5. So when h is greater than 0, in other words, it's positive, I move to the right. H units. If it is negative, then I move to the left. The problem with this, guys, is the formula is x minus h, and if we try to just memorize this part down here, we're going to goof it up. Take the argument, set it equal to 0, and solve. So if my argument here was x minus 3 for my argument, set that equal to 0 and solve. Again, I would add 3 to both sides. I get x equals a positive 3. That one went right. Try one more before we move on. What if I had x plus 2 as my argument? Set that equal to 0 and solve. You're going to subtract 2 both sides, and this might be a surprise. X equals a -2, so I went left 2. Why did I spend all the time here? Because my horizontal shift controls my asymptote. So my horizontal shift controls my asymptote, and it moves it away from the y-axis because it is a vertical asymptote, a vertical asymptote at the line x equals h. Okay, you have to write it as a function. X equals h. That's a line, and it gives me a vertical line. Make sure you know which way you move that asymptote. Domain. Set what you're taking the log of greater than 0. Another way of looking at that, the argument is greater than 0. That'll give you your domain. Your range is all real numbers. Alright, we'll go ahead and end this video here and start part 2 later.